name is Wes. I'm going to talk about Bluetooth. So I think Sam and Yusi did a great introduction. Everybody's already using Bluetooth. That's what we discovered yesterday. For those of you that haven't considered Bluetooth for a location deployment, it's something that you should consider. I think Bluetooth is actually a very good location technology when you compare it to Wi-Fi. As Phil kind of hinted at, it does solve some of the latency issues that you get with Wi-Fi location. Anyway, so let me just talk quickly about what's new in Bluetooth. So the latest rev of Bluetooth is 5.1. That'll start coming out, mid-year kind of stuff. But its main focus is on increased location accuracy. And so this includes both angle of arrival and angle of departure implementations for improved location accuracy. They're kind of talking sub-meter accuracy. We'll see what that looks like, but just something to keep on the radar. So how do you actually design a Bluetooth location network? It's pretty simple. You just sprinkle a little bit of location dust here, a little bit of location dust there. I think that's kind of the perception, at least from my side. I don't see a lot of customers doing location designs themselves. It's usually the vendor that makes the recommendation. And so through this presentation, I kind of want to change that because I think now we have tools so that you can actually do a proper location design. So what is today's state of the art? It's basically the red cup, which is the recommendation from the vendor comes to be place an AP every X number of feet. Whether it's 45 feet, 30 feet, 50 feet, whatever the recommendation is from the vendor, this is usually what you get. So is there a better way? I think there is. And so Ekahau recently, a few months ago, included Bluetooth design in their tool. And I think this is something that can legitimately be used for location deployments. And I actually do like the implementation, which is you design for the number of overlapping access points. That so Wi-Fi you don't want overlap necessarily. With Bluetooth you want tons of overlap because the more radios that you have listening, or more radios that you have contributing to the location calculation, the better the location calculation will be. So let me just, for those of you that haven't actually seen, this is the Bluetooth visualization within Ekahau. You're able to just select it as the very bottom one, and if you deploy, if you place a simulated access point that has a Bluetooth radio, it'll show up in this visualization. You have basically one knob to tweak, and that is the signal cutoff. I think the default is neg 80. For this, I changed to -70, neg 75, which seems to be pretty good. Pretty good for location calculations. So what's happening here is this is our missed office, and looking at this bottom right corner, right? So the visualization says there's in this corner there's only 2 APs that can hear each other for Bluetooth, so that for this particular use case, that'll work. But what I actually want to do is compare this to actuality to see if this is a valid, if you can actually use this for location design. While I get to that, so let me just give a quick overview of how Bluetooth location generally works. Think of it like GPS. So APs are beaconing out, and a client that is running, typically a mobile application will listen for all those APs, all the different beacons that come out, and report that up to the cloud to, or whatever the location engine may be, to perform the location calculation. So this is a real-time view of how the client is reporting back up to the location engine of how it's hearing all the beams. So I know it's kind of tough to see the numbers here, but the kind of the net here is that we're seeing 2 APs that are at under neg 75 dBm, which is what Ekahau thought it would be. Kind of if we look at these APs a little bit further away, you can see neg 90, neg 88, neg 85. And so if we actually compare, right? So Ekahau said that there's two AP, you have two AP coverage at neg 75, kind of in this bottom right portion of the office, and the real world, using a real client, that matches pretty closely. So I think that Ekahau can be used for location designs, and it's particularly convenient if you're actually if you're already doing a Wi-Fi design. The kind of caveats are, though, you need to understand where to place the APs. Just by having enough coverage isn't good enough for location design. The placement of the AP is actually crucial for location. If you're depending on the area that you want, good location accuracy, it'll really vary based on the use case. For example, on the left here is a grocery store where the grocer wanted location accuracy within the aisles. So they could tell somebody, if you go halfway down, aisle 7, you'll get to, you'll get to the cereal or something like that. The other piece is most location systems, the best location happens inside of the ring of the access points. So if you imagine drawing, putting a rubber band around the perimeter of all your APs, your best location will be inside of that. Versus, if you're outside of that, if you're outside of the rubber band, location accuracy can vary. So this is the point, right? You still have to know where to place the APs. The tool will just kind of tell you, do you have enough coverage to expect good location accuracy? And how about validation, right? So you do a design, that's pretty good. But when you actually validate the location design, typically, there aren't really tools for that. So you'll typically be using a vendor tool for that, or just walking around and using, if you've built an app on top of, for the location deployment, you'll be using the app or whatever it is to actually validate. So there's usually some sort of manual validation that goes into ensuring that there's, good location accuracy. So that's it for me. Thank you.